All right, welcome back, class. We've got one more video going over some information in regards to arrays before we move on. And in this video, what we want to do is spend just a minute and introduce you to the concept of multidimensional arrays. That's right, multidimensional. We've only been dealing with a single dimension up to this point. Now, if we all think back all the way back in Volume 1 when we did the Hyperion project, our Hello World application, we used a multidimensional array to represent the data for our map. So since we did that, I want to spend just a minute and talk about these multidimensional arrays so that if you want to go back and look at the Hyperion project one more time, you can go, oh yeah, that makes complete sense. Now, when dealing with multidimensional arrays, there's two different types of multidimensional arrays. We have rectangular arrays and we have jagged arrays. Now, we're not going to get into jagged arrays here. That is more of an advanced topic, and we'll save that for some other class that's not a 101 class. But the rectangular arrays is what I want to talk about. What if we wanted to create something other than just a single array, a single dimensional array? And let me just draw one up on the board real quick just as so we have something to compare against. So let's say that I had an int array called, I don't know, X, and we wanted to go ahead and set this guy up so that we had a new X that had 4 compartments in it, okay? So what would this actually look like? Well, over here, once again, a single dimensional array, so a single dimension. So 1, 2, 3, 4. And I'm going to draw my indexes a little bit different here. I'm going to actually put 0 up here at the top. This will just make it a little bit easier in following along with the multidimensional array in just a second. Which, of course, if this is 0, then this element right here would be a 1. So remember, that's what we're doing there. So this one would be a 2, this one would be a 3. But in this particular case, all we're looking at is a single column. What if we wanted multiple columns so that we could say, you know, on column 3, row 4, what's in that particular element?
Right, what if we wanted to use a grid to arrange things?
Exactly. So in order to do that, to create a multidimensional array, all we need to do is come in here with the following syntax. Let's say we'll use int again, so an integer, and now I know that I want 2 dimensions, so I'm just going to put a comma here. Close this off. So you could think of this as the comma basically is separating these 2 dimensions. Can't see them. Just there's one comma. That means we must have 2 dimensions. We can have another comma. What does that mean? Well, now we've got 3 dimensions, okay? So you can just keep adding commas, but at this point you really need to keep up with how your data is going to be laid out, because the more commas you add, it becomes much more complicated. So again, let me kind of see if I can erase these out just to make this nice and clear. I just wanted you to see the division between dimensions, or at least where we get 2 dimensions from. So we had this, and in this case, since we're going to do something like a map, let's call our variable map. And let's say that I wanted to do a new integer. So of course here I am. I'm going to go ahead and get this guy going. So new int with 4 by 3. Just because if we did 3 by 3, you really wouldn't be able to easily tell what's what. So 4 by 3, what's this going to look like? Well, basically, this is our first dimension. This is our second dimension. Okay? So if I was to draw that out, well, we have our first dimension again, just like we did above. And the first dimension, according to this guy right here, has how many compartments? It has 4. So 1, 2, 3, 4. Okay, very good. Now, our second dimension is 3. Basically, that means you can kind of look at as how many first dimensions do we have repeated in a way. That's kind of a weird way of saying it, but in essence, it's saying, all right, we have 3. So here is 1. I'll just put it down here. So that's our first dimension. Repeat. So here comes our second, I don't want to say second dimension, but because we're just dealing with 2-dimensional array, but second and third repeated first dimensions. Boy, that sounds weird. So second, third. So you can see that is where we get our 3 from right here. And 1, 2, 3, 4 is where we get our 4 from right here. Okay? So we could say that 4 is our up and down, and we could say that our 3 is going back and forth. Simple enough. Now you got to be really careful here, because obviously a lot of you guys are going to look at this and you're going to think, X and Y. Ooh, be real careful, because X and Y, well, you're dealing with a coordinate system now. This isn't really I mean, you can establish a coordinate system yourself.
A coordinate system is an idea that you can apply to things like a two-dimensional array. But in and of itself, there's nothing telling anything that this is X or Y.
That's right.
All the compiler cares about is that you have dimension 1 and dimension 2. How you use them is up to you. You could use dimensions 1 and 2 to represent X and Y. You could use them the other way and have them represent Y and X. Or you could have them represent something that's not even a graphical 2D plane.
Exactly.
So you just got to be really careful and not getting tripped up into thinking that, well, this dimension came first, so it's always going to be X for some reason.
Right.
It's not locked to a two-dimensional plane. It can be used for one, but it's not restricted to one.
So in this particular case, if I wanted to come in and put a piece of information, let's say, excuse me, over at right here. Let's say I wanted to put a 5 right there. How would I go about doing it? I would simply say that map location. Now, what location am I dealing with? First digit right here deals with this first column. So we're talking about position 0, position 1. So we've got a 1. And then what is our second one? It's a 2. Okay, so 2 equals 5. And that would put a 5 in that particular compartment right there. Okay.
Right, but look at what that's actually doing to the map. If you're trying to think of 2D coordinates, it's very common to think of X by Y.
That's right, so X going left and right and Y up and down.
But in this case, look at what the first dimension is. The first dimension is up and down. So up and down is generally considered Y, so it's almost like this map is laid out in Y by X instead of X by Y.
Exactly.
And really, this is just to match the representation given before, so that we build upon what we know about arrays into multidimensional arrays. But if we do that, if we hold that and turn that into a coordinate system, we end up with a 2D coordinate system that is Y by X instead of X by Y.
Right. Okay, so with all of that said, Logan, what I'd like to do is let's go ahead and jump over and just give a couple quick examples so that everybody sees working with this. Let's go ahead and start out with a new console application. And
all right, let's begin with the declaration. We want a multidimensional integer array, so I'll do int, open square bracket, comma, closing square bracket. Now we want to name this variable map, like we'd talked about on the whiteboard. And we'll say that is equal to a new int array. Now this time I want to specify the dimensions. So we'll say that this is going to be a 4 by 3 rectangular array.
And let's just turn around and do like we did on the whiteboard. Let's go ahead and set map location whatever and dump some, what was it, 1, 2,
yeah, let's do a map 1, 2, and let's set that to a value of 5. So we hold a 5 in map location 1 by 2.
Okay.
Now let's see.
And we can just, how do you want to do this next part? Because we can write it out and it'll prove that 5's in there.
Right, we can do some very simple right lines just to show, maybe some of the other addresses too, just to show that every other address in this made-up map is initialized to 0 because we use new int. So, I mean, we could show that as well. Now, of course, map 1 by 2 is going to have the 5 that we stored in it. So we're expecting a specific result with that one. But I'll try some other stuff too. And do a read line, of course.
Sure.
Hold up execution.
All right, so let's verify that we see a 5. And we see a 5.
Indeed we do. Now, what was that? Maybe location 0, 0, because we never set location 0, 0. Well,
okay.
It is a value of 0. Again, this is because we initialize the array, and so all elements we don't specify are going to initialize to 0.
Now let's have a little bit of fun. Go to 0, 1, 2, 3. So 3, comma.
Let me actually copy this line, and
Sure.
I'll drop in another coordinate.
All right, so I want to go to 0, 1, 2, 3. So 3, comma, 0, 1, 2. So 3, comma, 2. That should take us to the very corner of the map. And if you don't believe me, just think about this. Because plus 1, 3 plus 1, 4, 2 plus 1, 3. Because remember, 0 based, explicitly assigned.
So just like on the looping example, we saw if we were looping through a 5-element array, the highest index we could reach is 4 because it's 0 based.
Exactly.
0 through 4 makes 5 elements.
Exactly. So in this case, you've got that in place. So let's go ahead and print out what is at 3, comma, 2.
So 3 by 2 should, of course,
and that's going to print out a 5. Beautiful. Now, first change to 3 to a 4. Down, not in that one. I'm thinking on the right line. Yeah, just showing how either of these is going to put us out of bounds. Let's go ahead and run this. And out of bounds.
And this has thrown an exception, an out of range
out of bounds.
Exception.
Yeah, out of range and outside the bounds of the array. Okay, so let's close that one down and set that back to 3. Run it again. Make sure everything's fine. And beautiful. Let's close that out. Now let's set the 2 over here. Yeah, 2 at 3. So we're going to go out of bounds in the other direction. Let's run that. Again, so we have demonstrated that we are indeed at the bottom right-hand corner. As a matter of fact, go ahead and close out of that real quick, Logan. Let me jump back over here. We have proven that we were right here, and what we tried doing was going over, and we tried going down, and
right,
can't.
And trace those lines back out to the edge of the grid where you have the grid lines numbered.
Oh, yeah. So, of course, we're at 3, 2. And there you go.
Everything else is obviously off the bounds of that grid.
Exactly. Okay, very good. Now, of course, you can still initialize a multidimensional array. So, Logan, you want to go ahead and set it up so that you can...
Right. How would we use an array initializer? Because you remember, if this was a single-dimensional array, we could initialize it in a manner like this, where we'd have 1 by 2 by some numbers.
But now we're dealing with something that's a bit more complicated. We've got a series of rows and columns.
Right. What it is, yeah, exactly. We have a series of... I don't want to say series of arrays because we're talking about rectangular and not jagged.
Exactly.
But we are dealing with another... It's almost like there's another layer. This can't exist on its own. This entire thing now acts as a column inside the entire array. And knowing that, we could in fact do that. So we've got 3 elements across. Let me change these to zeros.
Okay.
And let's say that we wanted to initialize this entire array. Well, we know that this would have worked if we had had a 3-element single-dimensional array.
Mm-hmm.
But we don't. We have a 4 by 3. So we could take this entire thing, copy it, paste it, and let's see, we have 4 that we need to reach. Now, all of these have to be blocked in with further braces. I'm almost tempted to make a 2 by 3 just to show this off. Let me do that real quick. Or, as a matter of fact, let me just change this real quick. If instead we had 4. So now go back to that grid. Imagine that it is 2 tall instead of 4.
Mm-hmm.
That way this can now work and build. So if I build now, this works. And let me make sure these aren't out of bounds. Let me just set this to 0, 0 and comment this one out. Let me just comment all of them out.
Okay.
So we can build and run now. Of course, 0, 0 is going to be 0. We haven't said anything else that wasn't 0. But the program does in fact run. And look what we've done. This would have been valid for a single dimension. This would have been valid for a single dimension. So it's almost like we've combined 2 dimensions separated by a comma, also enclosed in outer curly braces.
Right.
So that's how you would literally describe the array using an array initializer. Now let's go back to the setting where we needed 4 by 3. Now, of course, we could copy one of these. Let me carefully copy out the comma and one of these blocks. So we could paste that in to have...
comma's missing.
Put the comma on the wrong side is what I did.
There we go.
And copy this one last time and one more. So if we build, we should be able to put everything back, and I'll show a cleaner way of writing that in just a second. So if we run, everything is in fact working. So look at what we've done. We've got where we had 2, so there's the 1st, 2nd, 3rd, and 4th. So all of that's working. Now a more convenient way of writing this, because of course now this is very confusing because you have a bunch of braces, you have 2 braces on the end. What you could do is separate each of the dimensions by adding a line return in the actual source.
Nothing like good old white space to help with readability.
So we drop this one, and drop the last one, and there we go. See, that way it actually starts to look like a grid now. Yeah,
it does. As a matter of fact, we can show initializing the 1, 2 to 5 up there in the... In where you're initializing everything.
And to do that, let me comment out these lines. So where we had assigned directly. Let's instead look for 1 by 2 if we were going by the old grid method. So we want to start up and down, start at 0, 0 being this element. Now we want 1, so let's move 1 down. This would be 1. And 2, so 0, 1, 2. So if we set this one to 5.
Okay. And do make it 8. Make it 8 instead, just so that when we show that, they're like, hey, yep, it's not the same old 5.
So starting at 1 by 2. If we run now, we actually found the 8.
Fantastic.
So that is, in fact, following the layout that was drawn on the whiteboard.
All right, excellent. Very cool.
So let's do something else now. We had talked about looping in the last lesson. Looping is, of course, a way where we can transverse an entire array. Have a piece of code that's smart enough to look at an array and show all of it. How would we show a multidimensional like this? Well, the easiest way of doing this, since we know it has only 2 dimensions, would be to use a nested loop. And let me show what that might look like. I'm going to jump down below one of our test lines, and let's begin a loop. I'm going to start a for loop, and I'll hit tab twice to bring up the template. Now, let's think about the way that we want to loop through this, because we have the option of looping row by row or column by column.
That's right.
The way I'm going to set up this loop is to loop in Y first, and because our array is set up as a Y by X style grid, that means this will be considered Y, so the outer loop is going to move up and down. Well, really in this case just down, but if it were to move forwards and backwards, it would be moving up and down as opposed to left and right.
Okay.
So I'm going to make the outer loop Y, and the length is going to be map. Now here's something tricky. Can we use length anymore? Because remember, this is how we were getting our number of elements for the loop. Well, before we write the loop, let's actually take a look at that. Let me comment out what's the skeleton we've been putting together so far, and let's see what map.length actually holds. Now, of course, I'll do a console write line. What is inside of, let's see, console...
That's missing, yeah, it's
I see capital, that's what it's... So map.length holds 12.
Ooh.
12. So this isn't going to be useful for transversing in a two-dimensional manner.
That's right.
We can't loop. I mean, 12 is not a valid coordinate on either of those. We saw that reaching 4 was going to throw us out of bounds. So going 0 through 12 is not going to be useful. What it comes down to is we need to get the length of each individual dimension. We need a length number that respects dimensions, that doesn't look at the entire array. And we can actually get that by using map.getLength. It performs the same function as length, except that it respects dimensions. As a matter of fact, represents the number of elements specified here. So given, basically what it boils down to is we have a dimension that can be fed to it. So we can use map.getLength. So which dimension? Well, let's look at dimension 0 first. Now keep in mind that dimension is 0 based. We've been talking about dimensions as dimension 1, dimension 2. But keep in mind that if you're accessing them directly, it's 0 based.
Okay.
So 0 is dimension 1. Now if we run, we see that dimension 0, or well, dimension 1, or excuse me, dimension 0 meaning first dimension.
Right. Has 4 different slots.
So that's useful. Now we have something that describes how many up and down if we look at our visual representation. We can also feed it length
1 and C3, and we do.
And so now we have left and right. So now we have some useful numbers. We can use get length 0 to get up and down. We can use get length 1 to get left and right. So now we can go back to our loop and finish it. As a matter of fact, I can delete the right line now. All right, Y. We're saying Y goes up and down. That is dimension, first dimension, dimension 0. So map.getLength 0 will allow us to transverse up and down. Now inside of this, we're going to do a nested loop, another loop that's going to say for every, I guess in this case, row, look at a specific column. So we can do for, I'll bring up the template again. This time we'll call this X, and we'll say map.getLength for dimension 1. So this way, for every row, we'll go column by column. So now that we're inside of this loop, let's do something to write out part of this element, or excuse me, part of this array. Now I don't want to do a direct write line, because then I would just list them all as 12 different lines.
Yeah, exactly.
So what I want to do is use the console set screen position, or set cursor position, so that we can say, all right, locate to an exact position on the screen, and that way we get to draw a grid layout. So if we do console.set cursor position takes in a left and a top. So left in this case, well, left is, by the way we have this set up, represented by back and forth, or X, and top will be represented by Y, so we should be able to plug in X and Y to the set position. And then at that position, let's write out the value held within the array. So console.write, and we'll write out map for Y by X. Now again, I'm using Y by X here because that's how the array is laid out.
That's right.
Y comes first, even though we're able to use Y as an actual positioning Y when set position. But we do have to remember that they're reversed inside of the array itself. So with this, let me build, make sure that there's no simple errors, and then run. And we see we have an array now that matches.
Yeah,
so we have
nice.
3 across, 4 up and down. The second row, third column has an 8 in it, and that matches our visual representation from the literal initializer.
Fantastic.
And
that's pretty much it, actually.
There's one one other thing I want to show. This is just bonus material now. I mean, that is the idea. We now have a nested loop that transverses the array, but we could do something else to make the number stand out even more. We could do a console.set color. Or is it set?
Set foreground color?
Oh, yeah, foreground color property. That's it. Let's set the foreground color to the map value casted to a console color. So console color for the map value. Now, of course, I'm casting directly instead of properly using console color dot red or blue or anything. But if we look at console color, we can see that it's an enum, so we can cast back and forth between them. But I mean, that's why I can cast from numbers back and forth to the labels. So if we set the color now and run, we see we have all the zeros became invisible. Well, color 0 is black.
And so change that 8 to a 14 and you'll have a yellow.
Black is 0. So if 8 was instead 14,
and there you go.
Yellow. If we changed all of these to something else, like to bring the grid back up, let me set them all to 7. So we'll use 7 kind of like a background color. So there's the whole array. Now, of course, double-digit numbers get a little bit tricky to represent. So what I could do is I could actually take the number out and just write something like maybe a 0 character. That way we don't break the grid when we do this.
Right.
So now the mapping, let me change it to something other than a number because that's confusing. Let me do a hash symbol. There we go. So now we're using that number to represent a color instead of a printed value. So we could drop a 14 there. We could maybe drop a few 9s down the center, maybe a 14 on the other side, or a 14 down in the corner.
Excellent.
So now we can start to draw using color. But again, same map idea. It's just using the values in different places.
Right. And with that, is there anything else you want to add in?
There is one other thing I want to touch on, and that is, now that we've looked at a way to loop respecting the coordinates as though this was a 2D grid, what if for some reason you wanted to take this array as you built it and list everything that it contains without respect to dimension? What if you wanted to assemble a loop that didn't have to respect the dimensions? You just wanted to dump all these numbers. So let's say you wanted an output of 9 or 7, 9, 7, 7, 9, 14, 7, 9, all in a straight line.
Right.
How would you do that? Well, if we go back to treating the array as a collection, we could use a for each to transverse the loop without respect to dimensions. And we do that by simply setting up a for each loop to work on the map array. So we could say for each. Let's see, let's call this, what do you want to call the elements held inside a map since we don't really have a name? We could call it location, we could call it room.
LOC.
LOC, I like that. So we'll have an integer called LOC, so like a location. For each location in map, do the following. And for this I'll do a console.write, or I could do a write line to do up and down. I'll do a write though.
Okay.
So I'll write out, I was just going back and forth in my head about which one I wanted to do. So I'll write that location. I might put a space into it. As a matter of fact, I will put a space into it just to keep some kind of separation. And let me also do a console
dot right line up there.
Just to separate this off the grid, because otherwise the grid might be sitting on that last element. So now if we build, no errors. If we run, we get this result. And let me actually turn the number printing back on inside of this one. And that is saying printing out the exact number value. So we can see the numbers arranged. Let me also take the 14s out. I'll replace them with
8s. Yeah.
So you can see as a grid, a colored grid in this case, or directly. So it's saying, all right, we suddenly don't want to respect dimensions. We just want to see the values, all of the values in the array printed out on a straight line. So it's like almost a serial
so you're looking at
representation.
your grid up at the top. You see the 797, and you'll see 797. Then the next one is 798, and then, as Logan just showed, there's 798. Then finally 797 again. And then 877. Exactly. All right.
So that's just a good thing to note. Because of the way for each works and that it treats it as a collection and simply walks through everything, you can use that to transverse a multidimensional array without respect to the dimensions.
Cool. Ladies and gentlemen, that is going to wrap up our look at arrays in the 101 class. Thanks a lot.